Well, hello, good morning. It's November 10th here, and I'm ready to have some fun with this radio. So I've been thinking about it since yesterday, how to get some fun out of this radio while I'm fixing it up. So one of the things I noticed when I was playing the radio yesterday was the sound was quite distorted. So that's kind of interesting. Why is it distorted? Maybe we can start working on this radio from that point of view. Distorted audio output. So there's a number of possibilities, of course. The radio is still full of bad capacitors, so a bad capacitor could be causing this problem. But there's other possibilities too here. One is it has a 6K6 output tube in it, when the radio is really designed for a 6F6. 6K6 should work okay, but there's better choices. 6F6 would be a better choice. 6V6 is probably a much better choice. 6V6 is more similar to a 6F6 than a 6K6. So this could be causing the distortion right here. Not terribly likely. Another possibility is the distortion is coming from the preamp tube, the preamp circuit. The distortion is really starting here. So either one of these tubes could be thrown off by bias problems. The biasing of this tube is done with a cathode resistor. The cathode resistor could be bad. Another possibility is the capacitor that's blocking DC from getting to the grid from the plate of this tube. Well, that capacitor is almost certainly leaky, so there's a good chance. This is what I think is the most likely cause. The grid is being pushed positive, less negative, or even into a positive zone from a leaky capacitor that's supposed to be blocking DC from this tube. So all these possibilities are here in the audio circuits. I guess it's possible in the radio circuits that's where the distortion is starting. But I would guess it's in here somewhere. So how to approach this in an interesting way, which is going to reveal something, rather than just jump in and start changing capacitors and go, well, voila, it's working now. Who knows why? Who knows what was wrong and who knows why? Must have been the capacitors. I like to go just a little bit further than that. So probably a good place to start is to measure the voltages. I have a diagram or a chart. There's a chart in the service manual. It tells you the voltages on tubes. So it's probably worth starting there and seeing especially the grid on this output tube. I don't want to be tuning in radio stations while I'm doing this, simply because the radio is pretty weak and I don't have any control over the radio station. So I think what I'll do is I'll fire a signal into the radio using my signal generator here. And then we can listen to the output, or I can even put it on the oscilloscope, and we can look for the kind of distortion that's happening there. And then as we make changes, change a capacitor, change the tube, whatever it is, we can hear and see the variation. That's assuming we can hear the distortion with just a simple signal coming out of this signal generator. We can certainly see it if it exists. We can see it on the scope. So maybe the first thing to do is to set up the oscilloscope to look at what signal is getting to the speaker, and set up the signal generator and get the radio receiving from the signal generator. And then we can start playing around, ultimately changing the capacitors out in the audio circuits. And that's really my intention at this point, is to clean out the old capacitors in here. But I do like doing it in a way that might reveal something more about what has gone on with the radio. Okay, so I think I got the order figured out now. Leave everything as it is. Get it operating from the signal generator. Get out the voltmeter, read the pin voltages on the audio tubes. Maybe on the other tubes too while I'm doing it. And see where all that leaves us. That's the first step. We'll have to kind of do it and see what the result is before making a decision around what to do after that. Okay, I think I've got everything hooked up here that I need to hook up. So I have the signal generator running here. This is producing a audio tone. It will sweep from 500 hertz, which is not as low as I would want it to go, but 500 is a good starting point, up to 10,000, something like that. Slowly sweep up. That's the sound that'll come out of this. That output is being fed into the phono input up here. Okay, we'll start by playing the radio first, so make sure it works the same as it did yesterday. I do have a connection to the antenna here that's coming from this signal generator, which I have not switched on, as I may not be interested in it. Play this audio, we'll listen to it come out of the speaker, we can look at it on the scope. The scope is hooked up right to the voice coil leads of the speaker. The speakers we're using, by the way, are mounted way up high. There's one of them, and the other one on the other side. Two in parallel to give us something close to the 3 ohms the radio is looking for. And that's an interesting question too. The speaker that has come with this radio is not the original, and my guess is it's an 8 ohm speaker. Is that going to play a role? I don't know. I don't know for sure that this is the correct output transformer that showed up. Could be from some other radio or speaker. I don't know. So even this could be implicated. Who knows? So we'll start by just feeding in the audio signal that only goes through the last 2 tubes, and we'll see what we get out of it. But first we listen to the radio. And I think we're ready to go here. I was also operating the radio on a lower than normal voltage, around 100 volts. That should be enough. But that too could have been part of the reason why there was distortion. So all kinds of possible reasons here. Okay. Here we go. Just one last check. Yeah, we're good. So, it's turned off here. So if you can keep your eye on this meter here. This meter doesn't go from 0 to 140, it goes from 100 to 140. So if you see the meter fall to what looks like 0, it's not really 0. It's something less than 100 volts. But this is showing the voltage at the outlet. And so is this guy here, but look, it's a little hard to see from a distance. This thing you can see quite easily. So that's the full voltage being sent, 115 on this meter. Actual voltage 117. Okay, pretty good. This meter's fairly accurate. When I hit the switch here, you'll see this meter just drop right off. You'll see the lights come on a little bit and stuff like that. There we go. Just kind of explaining what is visible in the video. So I know people may have questions about what's going on there. We'll see if this comes up at all. Probably won't. So we're around 90 volts now. So I'm going to compensate by increasing the input voltage like I did last time. Now we're running right around 100 volts on the radio. Okay, sounds just like it did the first time. We're up on the 9 megahertz band, but there's no real antenna hooked up. And we're not really trying to receive anything anyway. Just doing this. Just because you never know. You can't find stuff if you don't look for it. Okay, now let's switch to this input. Turn the volume down because I don't know what levels are happening. What levels are happening here? Very low. Fairly low level signal coming in. Okay, we'll flip to the phono input. Hopefully the button's working. Turn it up. Nothing so far. Okay, we'll turn up the input here. So this is running at a very low frequency right now. So we're going to jack it up. Ooh, that's going way too high. Let's try. So I believe that's a 2 kilohertz signal. 2000 hertz. Yeah, so we should hear that quite easily. I don't think I hear a thing. Okay, let's go up a level higher. Hear it now or never. Kind of sounds like the radio. We shouldn't be able to hear the radio with this button pushed. So this is a pretty dirty connector. It may be faulty. I've got everything turned up high here, so if it suddenly starts working, we'll be in for a big surprise. Let's just knock this back a little bit. That's quite a bit, actually. Okay. I don't want to scare the neighborhood here. It's not gonna show. Not a thing. Well, okay, so it's a possibility that this button is not actually working properly. It's a good possibility this connector hasn't made a connection. Let me turn this down a bit. I hear nothing whatsoever. I expect to hear something. Some kind of clicky sound. Okay, so if this isn't going to work, if there's something about the audio input here that has to be resolved, rather than get into that now, I'll revert to using the radio itself. And so what we'll do is first turn it down, put this onto any other button. Just pop this one out. You can take this out of here because it's not helping now. Set that there. Cut the output way back. Just leave that. Now we want this guy to be running. I'm on the 31 meter band, roughly in the middle. I think that's going to be 95 or something like that, 9.5. Unfortunately, that's right on the band change of my signal generator. Let's go down a little bit. I'd have to run out in the garage and look at the radio panel to find out exactly what frequency that is. But it's 9 megahertz something. So let's go up there. Okay, turn up the radio. Wow, there's nothing there. Oh. Was this guy cutting it off? Okay, let's revert back to the audio side of things here. Maybe that tone control seemed to be cutting everything off. Okay, so we'll go back over here. The low level input. Nothing heard. Nothing. That's the whole shooting match here. Oh, if this were to suddenly just come on, it could just blare. Got my hand on the volume control though. But it could blare. Okay, nothing. Okay, back to the radio then. Back to the radio. Push any button. Radio came on. Okay, I'm going to try to tune in, or we're guessing 9.2 or something of that sort. I have a fairly strong signal coming from over here. Okay, let's I'm going to get a better camera on the oscilloscope here. Okay, so when you're listening to the sound, to me it's very obvious it's distorted. There should be a nice tone, sine wave, kind of a pure sort of sound. I don't know what kind of adjectives to use exactly, but what I hear is a shrill, sharp thing. It's full of harmonics, making it sound like that. So you can see on the scope, even in the long shot, that's not much of a sine wave. Here it is a little more up close. So that's a pretty odd looking thing. That's what we're hearing. It should be a beautiful sine wave. I cannot make my scope trigger, so it's going to march across the screen like that. So I'm going to try a few things. First of all, I'm going to reduce the modulation level, see if that is somehow part of the picture. The answer is no. So that's not my signal generator. I know my signal generator produces a beautiful sine wave. That's what's going into this radio receiver. Now I'm going to tune the radio back and forth. When the signal is quite weak, it actually sounds much more like it should. It looks more like it should, but it's still distorted. Now if I can only stop this, just see if I can fool it into stopping here. So see that sharp corner right there? To generate that sharp corner requires a lot of harmonics. That's probably much of what we're hearing in terms of the harmonics. Okay, I can't look at that and tell you what's wrong with this receiver just from looking at that. What other adjustments can we make to the radio? We can reduce the antenna level signal. Just reduce it. Can we bring it up a bit? Now you can see the that sharp part is trying to, so you have a low enough signal, you don't get much distortion. That's not going to be too helpful for tracking it down. I can produce a higher frequency here. Let's see what that looks like. This is 1000 hertz. Let me speed it up. Speed it up and slow it down. Now, to me, what that looks like, the bottom is cut off. Cut off. You know, the word cut off usually ties in with things like bad bias on a tube. Not that that's what that necessarily is. It could be all kinds of stuff. Okay, back down to the 400 hertz. Just fooling my oscilloscope into stopping, more or less. Okay, so it's definitely there. Now, is it from the output tube, or is it from the voltages? Why don't we check voltage levels next in the radio? I think that would be a good idea. To do that, I might be able to do it. Yeah, I can think about how to go about doing it here. Okay, so I've had to change things because I cannot keep this gigantic antenna plugged in. It's just too inconvenient here on my bench. So with the antenna unplugged, the feed from the antenna terminal here is open circuited. So what I've decided to do is skip the whole front end of the radio, the RF part of the radio, and feed an IF signal right into the IF. Should amount to the same thing coming out of the speaker, unless there's something wrong in the front end that's causing the distortion that we're seeing. So to that end, I've got the signal generator ready to go just below 455. I've got a clip lead clipped onto the grid of the mixer tube, the signal grid of the mixer tube. Everything else is the same as it was, except I took the light bulbs out of the radio at this point. So I think we're ready to go. Yeah. Okay, we'll switch on. The output of this signal generator is going nowhere. It's just an open wire on my bench now. Here we go. Start them up. I've got a yellow capacitor here just to protect my signal generator a little bit. In case I've made a mistake. Maybe I think I've clipped it on the grid, but maybe I clipped it onto the plate because, hey, I'm me. But I don't think that's what happened. Okay, radio's warmed up. We hear nothing. Okay, volume down. We'll clip this on. Let's just turn it up a little bit and listen for. Let's listen for nothing. That's not right. That's definitely not right. Shouldn't matter what band I'm on. Just make sure I haven't created a short here. No. Why nothing at all? Nothing at all. Well, maybe it's looking for a stronger signal here. Oh, do I hear something? Yeah, I'm hearing things. Well, we'll give it the shooting match here. Okay, something has not worked out. Disconnecting that antenna has done something more. I can't imagine that. I'm on the wrong pin in the wrong tube. I don't think so. Pin 4 of a 6SA7. Pin 4 of a 6SA7. Radio's running with 100 volts, so it should be okay. 6SA7. You might say, well, why don't you just run it at the regular voltage? It's slightly inconvenient for me to do that and have the dim bulbs still in the circuit. So I'm keeping the dim bulbs in right now. 6SA7, pin number 4. Oh, that's not it. That's a screen grid. Grid I want to be on is either pin 5 or pin 1. Duh. How did I get 4? I got 4 by studying the schematic. Okay, power off. So good thing I have the capacitor there because it looks like I did something stupid. Now how could that be? I'm just going to take a moment and look at that schematic again. I hooked it up to a terminal that's labeled SG on the schematic. SG. Oh, signal grid. No, screen grid. That's what it is. We want to be on pin number 8 here in order to get the signal grid. Pin number 8. Oh, that's just a little difficult to get to. Okay, how about a wire coming off it? No. Huh. Okay, just a very high likelihood of putting a short in with this clip. a short, possible short in 2 locations putting this in. Okay, we're going to reduce the chance of a short. That looks good. And is that really pin 8? I don't think so. No, it's not pin 8. Not pin 8. That's pin 7. Pin 8 has a green wire on it. Green wires are often grid wires. Let's see if I can get in there. That's good. No chance of shorting. Okay, turn down the output here. Okay, back on. So what I'm hoping to do here is get the very same distortion coming out of the radio. That's what I'm looking for, and then we can continue hunting in the audio circuits, which are all down here. So I already got one capacitor changed, another one I did right here, and we have potentially a tube in there that's not going to do the job as well as maybe it could. No sound at all. Okay, so we're going to hook up. Okay, we'll just jack up the input level. You should be hearing it by now. Something I'm not thinking of here. $102 volts on the radio. The audio push button is out, so the radio should be operating. No matter what band we're switched to or anything. Flipped onto the wrong thing again. No, it's definitely 8 with a green wire. Something happened when I tipped it. Well, I got one more power boost on this guy. Let's go there. Voila! There we go. I just was too chicken to turn it up high enough. And what do we get on the scope? We get pretty much the same thing here. Okay, so I'm going to turn the volume down. Oh, I can't. That's the volume going up and down. It really looks like a tube is in clipping or something like that. Just a wild guess. Okay, let's try turning down the input slowly here. And once we get it down low enough, the harshness goes away in the sound. The volume gets very low. I don't know if you can even hear it, but it sounds much more mellow now. We're kind of getting underneath the cutoff voltage, so to speak. If you can follow that comment. Okay, now, with everything like this, we know the radio is going to turn it down here. We know the radio is now operating in the same inappropriate way it has been. We know the problem is coming from either the IF or the audio. It's almost certainly the audio. We're going to start checking some voltages here. I've got to get that voltage table ready. Yes, I'm chicken. Always chicken. And we're going to check voltages on the two audio tubes and see what we can find out there. Okay, so I printed out that voltage table, and I've taken the time to write down the pin numbers, because they're not on the table, which pin on each tube to test. Mostly it's plate and screen voltage we're interested in, but we're also interested in, oh, I missed that, control grid, a little voltage there we may want to check. This is the one that I'm most interested in. This is 13 volts. This is a drop on the cathode resistor for the output tube, which is where I suspect problems lie. Okay, and we should also be checking the grid of the output tube also, which I didn't mark on here. We'll worry about that when we get to it. So we start with the 6SK7. We're expecting, what are we expecting here? 210 volts on the plate, which is pin 8 of this tube up here. Oh my gosh, how am I going to get in there? Yeah, I don't know about that. It's really hidden from view. Pin 8. Just bring in the spotlight here. Pin 8. Oh yeah. I get to show you the back of my head a lot today. Pin 8. Well, it's right there. In fact, pin 8 is on a wire. And it comes all the way up to here. So we should have 210 volts on the meter. 210, I'm on the 500 scale, so 210 is just roughly where my finger is. Did I get it right? Right on. So it's right on 200 volts. So it's right on the money. So that's a 6SK, and then the screen grid should be 82 volts. I'm going to go down to the 150 volt scale, 82 volts, so right about here. Oh, now can I get to that pin? Pin number 6. So that's, I think the answer is no. I can't really get to it. Oh, wait a minute. 876. So on that great big wire, my great big wire going way over here. I believe this is the screen here. Right on the money. Very good. Okay. Now there's another 6SK. We might as well do that one right away. 6SK is in between these cans. It's this tube down here. Plate 8. Once again, plate 8. This is 8. So we're looking for 220 volts this time. So 220, just about straight up. That's around 200 on my meter. That's good. By the way, there's an instruction on here. All above values hold within plus or minus 20% when measured with 1,000 ohm per volt meter on a line voltage of 115 volts. 1,000 ohm per volt meter is a pretty crappy meter. You'd want to use that on the highest scale the whole time, or the meter itself is loading down some of these circuits. This meter is much better than that. Okay. Again, pin 8 and pin 6. Pin 8 and pin 6. Pin 8, I already did it. Pin 6 is this guy here. Okay, I'm on the big scale. So again, we're looking for 82 volts. Same as the other two. Probably the very same reading. A little higher actually, but good. Okay, basically they want the voltage to be there. That's really the need. Now we know all these tubes have plate voltage on them or they wouldn't work at all. 6SA7. The radio wouldn't work at all. 6SA7. Plate voltage, again, 220. They're all going to be very similar. Pin number 3. Pin number 3. Oh boy. Really? That's 876543. 3 is on this wire. 3 is on this wire. Okay, 500 volt scale. 200. Okay, and that tube also has a screen voltage, also 82 volts on pin 4. So if that was 3, that was 3. This is 4. And same voltage, just under 90 in fact. Okay, that's good. Now we're into the audio tube. So the 6SQ7, which have 195 volts on pin number 6. And the 6SQ7 is this guy right here. And we want to find on pin 6, 195 volts. Pin 6. So I'm counting here. Where's the little nubbin? There's the key. So 8766. Oh boy. It's kind of come in like this. Didn't get anything. Let's try that again. Pin 6. Let's count it the other way. Just cannot get a positive view of the key. There it is. There it is. Okay. Definitely see it. 8, 7, 6 would be this one right here. And nobody's home. It's got this capacitor connected to it. Pin 6. Did I get that right? This could be the problem. Is that definitely the 6SQ? Yes, it is. Let's try counting again. Here. Positive identification of the key. Definitely. 1, 2, 3, 4, 5, and 6. This is 6. There's nothing there. You can hear that in the speaker a little bit. That's a bit of a problem. Why is there no plate voltage there? Okay, that's definitely something to look into for sure. And we go 6F6. Pin 3 is a plate. It has 205 volts on it. Pin 3 of the 6F6. Once again, where's the key? Where's the key? There it is. So 876. 6 has a big green wire on it. 6 has a green wire on it going over to the volume control. It doesn't seem like a plate, does it? This is that pin. Doesn't really make sense. Pin 3. Okay, I've just counted it wrong or done something like that. There's the key for sure. 876. 6F6, eh? Trying to kid me here. 6F6. Six F6. According to this, plate is 3. Screen is 4. 3 and 4. That's what I've got here. 3 and 4. 3 and then 4. 3, this would be 4. No. Counting all wrong. I'm counting back from 8. I'm going 3 back. I'm going 1, 2, 3. I should be going 8, 7, 6, 5, 4, 3. Duh. 1, 2, 3. Yeah, it's really a good thing I don't do brain surgery. There we are. Okay, 200 on the meter. And then pin number 4. Also 200. 205 and 220. Should be a little higher on the screen. And then the cathode, 13 volts. This is a very important one. This is probably the cathode resistor. This guy sitting right here. So that would make that the cathode. The cathode's probably 8. Yep. And 8. Yep. Yep. And yep. So we're looking for 13 volts here. On a 15 volt scale, it should go all the way over. You get 12. 11 or 12. Could be as high as 20 if the plate voltage were higher. But I think that's actually right on the money where it should be. According to the table, it should be 13 volts. Let's check again. Just below 13. So our problem seems to be the plate voltage of preamp. Let's just double check and go all the way around that tube. 6SQ7, every pin. What do you say? Every pin. Anybody got any high voltage? Let's put this up at least on 150. Okay, here we go. Nothing there. Nothing there. Nothing there. There's no pin in there. Oh yes, there is a pin. I got a negative voltage there. That's probably one of the plates. Okay, and next one. This is where we're supposed to have a big whopper. Nothing there. Next one. Nothing there. Nothing anywhere. Next one. Tain't no B plus on the audio preamp tube plate. So how's it get there? Probably, let's see, to this pin where there should be voltage. I see a resistor here. 470. What's on the other side of that? Hey, lots of voltage there. But on this side, nothing. So we could have this capacitor could be shorted. That would be a bad thing. I mean, that resistor would be pretty hot, probably. And what do we get on the other side of this capacitor? There's nothing there. And that's the green wire carrying the audio. You wouldn't expect anything there. So why is this capacitor right between the audio here and the plate over there? I don't know. Then we have this capacitor that's been installed. Assumably it's correct. It's a 1.5K high performance HP. 1.5K. Well, and it's not going to be shorted, I don't think. What's over here? Nothing. So we're looking at a schematic, Oh yeah, there's another capacitor, this guy. And oh. Hello? Yes? Why are you calling? No, there's really no business here. So, no, but I'm not interested in whatever it is you might be selling. So thanks for calling. Bye. Bye. But no, I'm not going to continue answering questions. Bye bye. Yeah. Tell us. Yeah. Yeah, seriously, he's playing the game where I'm saying I'm not interested. He goes, oh, why is that? Keep you going, keep you talking. But I'm not talking anymore. Okay. Back to what I was doing. Right. So I was going to look on the schematic and figure out where this pin should be getting its voltage from. Probably from over here. Because there's lots there. So this is probably an open resistor. And then the question would be, well, why is that resistor open? And it went open on its own. Or something forced it open. If it was a shorted capacitor, it would probably burn it. And you'd see it. That's my thinking anyway. Okay, what's happening there? Schematic. Let's take a look. So this is the wiring diagram. I'll make sure of the part we're dealing with here first. And let me just get my sights set here. So we're right opposite. We're right over in this area. There's an R, there it is right there. R15. So we want to find R15 on the schematic. And it's right near, well, it's actually part of this tube here. Whoops. R15. Let's just zoom in a bit. Show me R15. R13. R8. R11. R16. Well, it's supposed to be right on the plate here. I should be able to follow this and find R14. Oh my god, I forgot what I'm looking for. R14, R15. Can you believe it? Yeah, that phone call disturbed me so bad. R15. Okay, I saw it up here. R15. There it is. 470K. And this is the B plus supply line here. You can see it coming from the power supply right here. Coming up. Can't get through R15. Now, if this guy were shorted, would cause problems, but it wouldn't blow this guy up. And if this one's shorted, likewise, if this one's shorted, I could blow this resistor up, but again, we tend to see it burned. So we need to check the impedance or resistance of the plate circuit to the chassis. Then we'll check that capacitor. And then we need to cut this resistor out and see what's going on with it. So we want to check C28. Don't really have to know where it is. Not unless there's trouble. So first, plate resistance, then this resistor is next. Okay. Power off, or I'm going to have some really interesting test results. I'm going to measure resistance using my multimeter. I could continue using this guy, but let's bring this one out. I'm just sitting on the shelf, feeling kind of left out. Plate resistance. Let's put it over here where I won't knock it down. What did I say? Plate resistance of which tube? Duh. Let me just pop that thing. yeah, plate resistance. Yeah, of the 6SQ. So we want to get on the plate of the 6SQ7. The plate of the 6SQ7 is pin 6. I want to read it to the ground. Pin 6. 1, 2, 3, 4, 5, 6. That's where everything adds up. What do we get? Let's check. Meter's working. So there's no short here. 2 meg scale. Yeah, there's nothing shorting here. So now we'll read across the resistor. It's supposed to be 470K, and we're in the 2 megohm scale. Maybe it's just gone really high. No, I think that's our problem right there. So what we're going to do, we're going to cut one leg of it. I mean, it's pretty convincing. It's open. I mean, how's this going to... Suddenly it's going to show up with resistance? She said doesn't work. Yeah, meter's good. That is the guy who's causing the trouble, I think. Cut him right out. You never know. Looks just fine. So probably what's happened in here is the lead, which connects to the carbon piece inside here, is probably separated. It probably isn't making contact anymore, but who knows for sure. So I'm going to stick another one in there and see if that doesn't clean up the radio. Okay, resistor's installed. Let's give the radio another try here. One of the things I just realized is I never actually tuned my signal generator to 455. I left it at 444, so that might have been part of why it's a little bit weak. But there's no question that that resistor was a bad guy. He's out of there. Okay, just neatening up a little bit before applying power. Okay, volume down, because there's liable to be a lot more volume this time. And signal generator level down. Power on through the dim bulbs. There they go. All is normal. Still have to turn it up quite a ways. Okay, let's take a look at what's showing on the oscilloscope here. Wow, look at that. Looks a lot more like what it should look like. Maybe the level's a little low, so I'm going to crank it up here. Oh yeah, that definitely... It's a very low level we have here right now. Turn down the volume. There we are. Well, there's a lovely sine wave there. That's full volume, but I can crank more signal in from the signal generator. Let's give it all it's worth here. You see the AVC action happen there? Okay, a little higher frequency. Just turn my microphones down a bit. Lovely. Very good. Okay, so, and what is the voltage? We might as well take a look at what it turned out to be. So looking here, okay, I think we're looking for 195 volts, so it's basically not quite straight up. It's quite low, still quite low. Maybe more to the story here. So I did measure with an ohm meter and didn't find a low resistance there. Oh, you're looking at the wrong thing there. Don't look at that. Look at this. Okay, voltage test. So this is on the 150, and we're coming up around 100 volts. Got 103 on the radio. That's probably depleting all these voltages a bit. Why don't we give it the full Monty here and just see what happens. Okay, full Monty. Okay, so I'm going to stop going through the dim lights. Well, that's quite a difference. Oh, went up, coming back down. So we're still hanging around 100 volts here. Well, they're right around 100. Around 100, and they really want 195 there. So there's something more going on. It could be the reason for the defective resistor. It may be one of these, this capacitor. You know what it probably was? Probably this one that he changed. It's probably a dud. And that one may have, the one here that was here previously, may have killed that resistor. You'd think he would find the resistor though. If you could find a single capacitor like that. Well, this capacitor was left disconnected. I wonder if that was part of a testing program somebody was doing and they just never figured it out. That's possible. It's possible. It's not hard to find a lack of B plus though, and that's a pretty easy thing to do. Or the resistor gave up the ghost after the fact, which is a little hard to believe too. On the supply side of the resistor was the regular voltage, I'm pretty sure. I don't know. Let's check. We gotta go back. We gotta turn them on again. The supply side, I mean, obviously the left side can't be higher than the right side. Okay, I'm gonna give it full. Give it the full Monty here. Okay, once again, now this is another thing too. See it slowly drift downwards? That's kind of odd. Okay, is that happening on the other side of this resistor? See, there's lots of juice on the other side. There's the 220. And it wants it like out of this business closer to 250 here. It wants 195 left over, but what's left over is only that. It should be 195. It should be right off the scale here. 195. It should be almost the same. There should be almost no drop on this, but there's quite a drop. Well, you know, as a guess, well, it's got that capacitor and that one. Power off. I measured the resistance to the chassis and it seemed okay. This is a very crude way to test capacitors though. You're looking for something seriously wrong with them. First of all, is there any voltage left in here? Nope. Nothing. Okay, So reading resistance. Repeating what I did before. This is across one suspect capacitor. Across another suspect. This is the new one. Yeah. And then this black guy here. Resistance to the chassis at this point. Ooh, we got something there. No, we didn't. 2 megohms. I had it on a bit of a low scale. Ah, negative, so there's a bit of voltage there. There's a 0 there. What is this terminal? This terminal is, it looks like there's a wire going to a ground terminal back here. Yeah, there's a wire going right to the chassis from here. That's a ground point. And it's shared out across a couple pins. Three of them are tied together. Any one of them is a ground. It has nothing to do with this guy or this guy. You should look on the schematic at the 3 capacitors that are connected to this point and see if any one of them could be a bad actor. Well, the only one that really could be is this black one. It's the only one going to the ground. Tested okay, but the ohmmeter is a lousy test. Let's try it again. Let's go higher. On the 28 megohm scale. Show me a leak. Minus again. Minus, we get a minus one way. Open circuit the other. It's always that same voltage, minus 3.32. It's not depleting. Well, that's a resistance. What if we actually try to measure the DC voltage there? What if we give up on this meter? I don't know. What's the matter with you? I'm having more and more trouble with this meter all the time. Okay, unfortunately on the 2 volt scale, what is the voltage at that spot? More than 2 volts. That's right, it was 3.3. Oop. Now it wants to say 0. Minus 6. I can't believe any of this. Can't believe any of that. Need some reassurance. Well, that's pretty reassuring. So there's a voltage just sitting there. going down very slowly. Can't achieve any measurements if that voltage is sitting there. Oops. Well, it's got a lot of capacitors hooked up to that one spot, but just wouldn't expect that. While this is discharging, let's take a look at the schematic, and we'll sort out 3 capacitors off this one terminal point. So we'll start with this diagram here. So this is the point. So we got one there, a capacitor here, yeah, and a capacitor here, just like they are. So that's 31 and 32. Okay, so we go up here to where R15 is. Here it is here, the one I just changed. 32 is the grid blocker that we should be concerned about. 31 is conveying nothing. 31's kind of involved with the tone control a little bit. It's to keep the tone control from drawing current. Now if we move this tone control around and we see that resistance go up and down, that would implicate this capacitor. It doesn't actually go to ground. Yeah, it goes to ground here. Yeah. And then this is C28. That wasn't the one we were looking for. There's another one. Was it 28? Oops. 28. So 28. 120 picofarads, 0.05, 0.01. So either 32 or 31 has been changed. So one of these goes to 6. Well, the only one that swings, well, they both head over for the output tube, but I'll bet you it's a dummy pin connection there. So the one that's been changed out goes to, let me just look myself here, pin number 8765. So 5, the one that goes to pin 5 on the output tube. Oh, lucky they wrote the number 5 right there. Oh, that's the tube number. Number 5, tube number 5. Oh, look at that. There's the little nubbin. 1, 2, 3, 4, 5. Okay. So the 0.01 has been changed with a 1.5K, whatever that is. So I doubt this guy's causing a problem. That's also protecting the grid voltage, which we measured was kind of okay over here. So the problem would have to be either this one or this one. This is the more likely one because it's a big paper one. Big paper one comes into the tone control. If I manipulate the tone control and we see the resistance of this line go up and down to the chassis, then we know it's this guy. Let's try that. Okay, so we're going to clip on our unreliable meter, and we want it to clip onto, oh, it's not like I've not already lost my mind. The potential of that spot right there. So we're just right here. Hopefully that's drained out some DC. Well, we have a number there and it's going up, so something is recharging. We'll do the tone control thing, just see if anything happens at all. Doesn't have any bearing on this. So where's a 3? Where's that voltage coming from? It could be coming right from these capacitors. That's awfully high though. These capacitors get moisture in them, they can turn into little batteries. They're crappy batteries, but some of them are in high impedance circuits, and it doesn't take much charge to throw things off. So a crappy battery that can deliver a tiny charge maybe is enough. So really didn't reach any conclusion here. The voltage is just going to work its way back up to 3. That is curious, isn't it? So curious, I don't know what to say about it or do about it. So, so we solved the major problem here. Now the secondary problem is what caused the major problem, and is there something more going on? And you know, I'm on my way to replacing all these anyway. I think that's what I'm going to do tomorrow. I think I'm going to leave it like this. Tomorrow we'll do the audio capacitors, 1, 2, 3. Find out how big this one is. It's probably correct, but I don't know. And then we can also check these old capacitors. I haven't cut one out yet. To see if they're generating voltage on their own. I can do that with one of them right now. Well, just a last bit of fun. I'm going to nip one capacitor free here. Oh, yeah, I took this off. Let's put it back on. Now, it's not coming from that capacitor, I don't think. Okay, we'll put it on the capacitor itself. Except I don't know where the capacitor is connected. Voltage there, so we'll read to the other side of the capacitor. So all that's happening here is the voltmeter is connected across a capacitor that's no longer in the circuit. I'm going to put a short on the capacitor. Okay, I'll give that a moment. So what I believe is happening now is I'm draining down the charge that's in the capacitor, but the capacitor is working like a battery. So it's got some EMF in it itself. So this will bring it down to a certain point. Take the short off, put the voltmeter on, and we should see the voltage going up, and that tells me the capacitor itself is generating voltage. Believe it or not. Here we go. Fairly quick on this. Well, I don't know. I mean, actually, we just take the meter off. The meter itself is going to draw a bit of charge out of the capacitor. It's a terrible battery, so just a little bit of charge drawn out. Turn off some of my equipment here. Okay, now we'll put the meter on and pull the voltage down very quickly. That's kind of what you saw there. You saw 95, 86, and 75 now. But it won't go to 0 because the capacitor is a battery. Okay, we're going to leave it at that. Tomorrow I'll clean up the audio circuits. We'll see if we can get the audio part working really well. There's another capacitor here. And everything past the detector. Get that working well. That'd be great. Lots of fun today. Thanks a lot for watching. And hopefully we'll have some more fun tomorrow.